Okay, guys, so I want to go ahead and solve a couple of more problems from your homework from section 4.2. I just posted a video a little bit ago about a couple of examples on how to solve certain types of exponential equations, where of course you can create the same base on both sides. We will see another category of these equations in section 4.5. where we have to use another approach. But for this section, all of our exponential equations can be solved by using the rule that I wrote on top of the board again, because of course we can always create the same base on both sides. Anyway, so I'm gonna go pick up one of the problems from your homework assignments and see if we can follow the steps we followed on those previous examples, and see if we can solve this equation, okay? So this is number 75 in section 4.2, and the equation says 2 raised to the power of 3 minus 2x equals number 8. Okay, so we're asked to solve this exponential equation. And by the way, one of the reasons I believe they call it exponential equation, maybe that there is a variable x in the exponent, and hence they refer to them as exponential equations. Anyway, so how do we solve this equation? Well, again, as we said before, the logic is if we're going to use the rule above, we need to make sure on both sides we have the same base. So now on the left-hand side, of course, the base is obviously 2. So we just have to ask ourselves, can we represent the right-hand side, which is 8, as also in base 2? And of course, the answer is yes, because 2 cubed is 8. 2 times 2 times 2, which is the same thing as 2 cubed, what happens to be 8. So that's our next step. So we're going to rewrite this as 2 raised to the 3 minus 2x equals to 2 cubed. So now we're ready to apply the rule, because as you can see, we have exactly the same bases. So the rule says now we can drop the bases and set the exponents equal to each other, which would then imply 3 minus 2x must be the same as the exponent there, which happened to be 3. And now we're just going to solve this linear equation for x, which should, of course, give us the final solution. So there are, of course, a couple of ways we can isolate the x. The first thing I would do here is I would subtract 3 from both sides, so we can isolate the x term. This is one way. So now we have negative 2x equals to, of course, 0, 3 minus 3. And of course, to solve for x, we have to remove the x coefficient negative 2. So we'll do that by division. Divide both sides by negative 2. And of course, 0 divided by any number is obviously 0. So x will be 0. And that is our solution for this exponential equation. Okay? So I want to, now these equations, of course, you're not going to be asked to check them. But of course, as you know, you can always check any equation to make sure that you have found the correct solution, but these are not required to be checked. But in this case, it's pretty obvious that this solution makes sense, because as you can see, if x is 0, if you go to the original equation, replace x with 0, of course, that tells you that this becomes 2 times 0, which becomes simply 0. Negative of 0, of course, is still going to be 0. And so all you're going to have is 2 raised to the 3rd power minus 0, which is same thing as 2 to the 3rd power, must be 8, which of course is correct, because 2 to the 3rd power, which is 2 times 2 times 2, which happened to be the same thing as 8. So you can see that the solution does definitely work in the original equation. But this is something, an option. You don't have to always check every equation. It's a good idea. But some equation, of course, as we saw previously in our course, you had to check them by the type of problem equation they were. In other words, you didn't have the option of check them or not check them. You had to check them. But for this equation, these equations, it is definitely an option. Anyway, so I'm going to go ahead and solve another one for you, which is another one of your homework. This one is number 77. And it says e raised to the power of 4x minus 1 equals e squared raised to the power of x. So we want to solve this exponential equation. Well, there is definitely a good news here. And the good news, of course, is that in this case, you can already see that we do have exactly the same base. So as you remember the last couple of cases, we had to create the same base on both sides. But this time the base is already given to be the same. The only bad news, if there is a bad news, but the only problem, of course, is that if you notice on the right-hand side, you do have two exponents on top of each other, where, of course, our rule says you must have only one base and one single exponent. So, of course, the left-hand side is already okay because we do have one base and one exponent, but the right-hand side has to be adjusted so that we do have only one exponent, and then we can go use the rule. Notice again, we do have the same basis, so that part of the problem is already taken care of. Okay, so we're going to rewrite this as e raised to the 4x minus 1 equals, of course, as you know, the rule of exponents, two exponents on top of each other, you must multiply them. And of course, 2 times x becomes 2x. And hence, the right-hand side becomes e to the 2x. So now you're ready to apply the rule because you can see you have exactly the same basis. And by the way, as the rule goes, you know, in math, when we use letters, it means, of course, that we do have a lot of generality, a lot of freedom. So that a could be, of course, any number. And so in this case, of course, it happened to be e. As you remember, e is a fixed constant in math, about 2.718, approximately, something like that. And as you also know, you have a button on your calculator that can give you the value of e. But regardless, e is a number. And of course, in this case, they both happen to be base e. So then by the rule, we can drop the bases and set the exponents equal to each other. So that tells you 4x minus 1 must be the same as 2x. So once again, we have ourselves another linear equation to solve. And of course, we will have to isolate the x. So in this case, I'm going to go ahead and have my x isolated on the left-hand side. You can also do it on the right, but I believe it will be nicer in this case to have the x on the left. And so first, I'll remove the negative 1 by adding 1 to both sides. So now we have 4x equals to 2x plus 1. And to remove the x from the right, so we can only have x on the left, we will subtract 2x from both sides. And of course, that reduces to 2x, 4x minus 2x, and that becomes, of course, plus 1, because 2x and negative 2x cancel each other. And of course, to solve for x, finally, we'll remove the 2 in front of the x, so we'll divide by 2. And so our x happened to be 1/2. I know it's a little bit kind of condensed on my little board. So this was the board that I could borrow from my granddaughter. She had a board she was using also, but she said she didn't need it for a while. So I'm taking advantage of that, and I'm using her little whiteboard to show you this. So I do apologize the fact that I don't have too much room. So some of the stuff may be a little close to each other. But anyway, as you hopefully can visit this video a couple of times in case you have any question about some of the writings. Okay, I'm gonna go ahead and stop here, and maybe I'll do one more example, and then I'll go ahead and quit on this video. So I'm going to do one more problem from your homework. This one is actually going to be a bit interesting, a little bit more. Of course, all of them are interesting, but this one is going to require something that you may have not thought of anytime recently. So this is our problem. I'll go ahead and do 74. 73 and 74 are exactly the same steps. It's just different numbers, but the same exact process should work for both of them. So let me do 74. And also that's good because 74 doesn't have the answer in the back. but 73 does. So hopefully once you see 74, that can also help you with 73. Okay, so here's our equation. We have 2/3 raised to the power of x equals to 9/4. Okay, so there is another exponential equation, and once again we want to solve it. In this case, of course, most likely we'll end up using the rule, which says, again, if two expressions are equal, they have the same base, the exponents must also be equal. So once again, in this case, we can see that we already have base 2/3 that shows up on the left-hand side. So logically, once again, if you're going to use that rule, we have to make sure the right-hand side can also be represented or rewritten with base 2/3. Well, there is a little bit of observation we need to make here, because one thing is for sure, that I think we can all agree that 9/4 can be written as 3/2 squared. That I believe we can all agree with. And why is that? Well, of course, as you know, the rule says when you want to square, or when you square a fraction, the rule says you have to square the numerator over, and then also you square the denominator. So in this case, obviously, as you square 3, that gives you the numerator, which is 9. Also, as you square 2, you get 4. So you can see that it is definitely the same thing. So, but the question was, why is that going to help us in this case? Well, because now you can see at least that you did bring in a base, except this base doesn't quite match your base on the left-hand side. So the question is there any way I can maybe reciprocate one of these two bases? And actually, logically, it doesn't matter. You can make 2/3 become 3/2, of course, by making an adjustment. Or you can make 3/2 becomes 2/3, also by making adjustment to your, obviously, exponent. And it works both ways, so you ultimately have to decide which way you want to do it. But for me, I think I'm going to go ahead and make the right-hand side, change it to 2/3 instead of 3/2. In other words, I want to see if I can reciprocate the base, in this case 3/2, to make it 2/3, which becomes the same as this base, and then we can follow and use the rule. So there is a very nice shortcut rule, you might have seen it before, that says, okay, there is a way, if you have a base that it happened to be a fraction, there is a way to actually reciprocate that fraction, but the only thing you have to do is you have to make sure that you also, as you reciprocate the base, you have to change the sign of the exponent. In other words, it says that a over b raised, a over b raised to the power of n. Again, this is for any number a and b, also for any exponent n. This is the same thing as b over a. In other words, reciprocate the base, but then you have to also change the sign of your exponent, which becomes raised to the negative n instead of n, okay? I'm sure you have seen this, well, there is a rule, obviously tells you how to make negative exponents positive, and this actually comes from that. But you might not have seen this shortcut. So anytime you have a fraction raised to any exponent, if you want that fraction or that base to be reciprocated, you can reciprocate it. You just have to make sure you change the sign of your exponent. So then if I apply that, the rule that I just gave you or wrote for you to the right-hand side, well, first of all, the left-hand side is still going to be the same thing, which is 2/3 raised to x. But then the right-hand side is going to be rewritten based on this rule as 2/3 raised to, except instead of 2, we change that to -2 by this rule. And now you can see you're done, because now you have created the same base, which means, and of course there's only one exponent, which means you can now drop the bases and set the exponents equal to each other, which will then give you your solution x equals to -2. Okay. Anyway, I hope that this few problems out of your homework assignment can help you. Don't forget, guys, as I mentioned before, If you have question about these problem in these videos that I'm gonna always provide for you, or if you have question on other homework or other topics in our sections that you want more clarification, please don't hesitate to message me through the Blackboard and let me know what's giving you a hard time, and then I'll try to see if I can make some more videos for you dealing with that issue of the problem that you're dealing with, and then hopefully put that on YouTube for you. Okay, well, thank you guys. We'll talk to you soon.